The topic of this problem is circuits with dependent sources. The problem is to determine the output or load voltage V sub 0. We have the circuit which is drawn below. It has a 10 milliamp source on the left-hand side of the circuit, and it has a current source on the right-hand side of the circuit, which is a dependent source. It's a current-controlled current source, where the current controlling that current source is the current I sub 0 through the 3 kilo ohm resistor, downward through the 3 kilo ohm resistor. The output voltage is the voltage across the load resistance, which is 4 kilo ohms. So in this case, the output voltage is found in this kind of in the center of the circuit across the lower element in the lower left part of the circuit. So in order to solve this problem, we have to use Kirchhoff's laws. And we notice that this is essentially a 3-node circuit. We have a node at the top of the circuit, we have a node at the bottom of the circuit, the ground node, and we also have this node kind of in the center of the circuit between the 2 and the 4 kilo ohm resistances. So we're going to solve the circuit, first of all, using Kirchhoff's current law, and we're going to sum the currents into the top node, which we're going to designate as node 1. And so if we do that, then we'll end up with the following equation. It's Kirchhoff's current law, and instead of summing the currents into the node 1, we're going to sum the currents out of node 1, just to show that it doesn't matter whether you sum the current into or out of the node, just so you're consistent throughout the problem. So it's KCL out of node 1 at the top of the circuit. So first of all, we know that we have 10 milliamps flowing out on the left-hand side of the circuit. We also have the voltage, which is across the 2 kilo ohm and the 4 kilo ohm resistances, that results in a current which is going to be V1, the nodal voltage associated with node 1, divided by the 2 kilo ohm plus the 4 kilo ohm resistance for that particular part of the circuit. We also have the voltage which is flowing through the 3 kilo ohm resistance, which is I naught, or I sub 0. It's going to be V1 divided by 3 kilo ohm. And on the right-hand side of the circuit, we have a current flowing into the top node, which is going to be 4I sub 0. And so that's all the currents flowing into node 1. And so the sum of those current at any instant in time is going to be equal to 0. That's our first equation. We notice in that equation that we have two unknowns. We have V sub 1 and we have I sub 0. So we need another equation that relates V sub 1 and I sub 0. And that's fairly easy to come up with using Ohm's law. We know that the voltage V sub 1, which is the voltage from the top node to the ground node, is the voltage across the 3 kilo ohm resistor. So V sub 1 is equal to I sub 0 times 3 kilo ohms. So that gives us our second equation, which is independent of the first equation. So we have two equations and we have two unknowns. So if we go through and we solve for the nodal voltage, then we'll have a nodal voltage V sub 1, which is equal to 12 volts. If we know that, we can step back and we can use our voltage division that we've learned earlier in the course to find the voltage across the 4 kilo ohm resistor. Namely, V out, V sub 0, the output voltage, is equal to the 12 volts, which is dropped across both the 2K and the 4K resistances. And using voltage division, we know that the amount of that voltage drop across the 4K is simply 4K divided by 2K plus 4K. And so that gives us an 8 volts for the voltage drop across the 4 kilo ohm resistor. So V sub 0 is equal to 8 volts, and we could have just as easily have written that as V sub 4K. the output across the load resistance 4K.